Okay, so video number 2. Hopefully I can get this one a wee bit better. You can see half it, but sure, we're learning. Moved the book already. Get her back up. So another data and statistics question. And as I said previously, just go around, label all bits of information they give you, and then we'll figure out if it's going to be a confidence interval for a mean, confidence interval for a proportion, or your null hypothesis, alternative hypothesis, doing your hypothesis testing. So the principal of a large school claims that the average distance from a student's home to a school is 3.5 kilometres. So this is our U. In order to test this claim, a sample of 60 students from the school was randomly selected. The students were asked how far from the school they lived, the mean distance from these students' home to the school. So from these students, so if you're unsure what to call the 3.5 kilometres, keep reading on, and then once you see these students, so that's your sample of students, so this here must be your x with a little cap and a standard deviation of 0.5. Test the principal's claim using a 5% level of significance. As I said before, the 5% level of significance just means a 95% confidence interval. The only confidence interval you have to know in your Leaving Cert course, unless they give you a stated one to work with. Clearly state your null hypothesis, your alternative hypothesis, and your conclusion. So work through it the same way. Null hypothesis is a statement of no change. So your mean is 3.5, what you labelled your U, kilometres. If you wanted to put English to it, the mean distance from a student's home to school. To school was 3.5 kilometres. And then your alternative hypothesis, U is not equal to 3.5 kilometres. Now you're going to have to see do the values lie in the critical region. See do the values lie in greater than 1.96 or less than 1.96. Because at the 5% level of significance, or your 95% confidence interval, critical regions Z bigger than 1.96. or Z is less than 1.96. So remember, the bit I cut off in the previous video, it's probably going to be the same now. If we're in this region above 1.96, we're going to reject the null hypothesis. If we're in this region somewhere down here, where it's less than minus 1.96, in the critical region, we're going to reject the null hypothesis. And then if we're in this region here, we're going to fail to reject. Don't accept, fail to reject. So we're going to have to work out our Z value. And again, they give us the sample size. That formula simply came. Page 35 of your formula book. One sample Z test. See it up near the top. And just lob that into your calculator once again. .09, so 3.1. It's very big Z score there. So we can safely say it lies within the critical region. So when it lies in the critical region, we're going to reject the null hypothesis. We're going to accept there the alternative hypothesis there. rejecting the null hypothesis, we're going back up to what we said at the start. Here it means the mean distance from a student's home to school was not 3.5 kilometres. So therefore just 3 wee dots. Next one. I'll move it up now. So in the above sample of 60 students, so again, just label each of the figures. 20% of them live within 2.5 kilometres of the school. Find the 95% confidence interval for the proportion. So last time we looked at the confidence interval for the mean, this time confidence interval for proportion. There only is 2 confidence intervals, it's either going to be a mean or proportion. So there's no excuse to get that wrong. You see proportion, you see a fraction, you see a percentage, you know that's what you're going to be using. So find the 95% confidence interval for the proportion of students from that school who live within 2.5 kilometres of the school. So your formula for this, p hat, just the proportion, 20%, minus 1.96. And here the error, the standard error of the proportion is this. So the proportion is going to be the same as the population, as n is bigger than or equal to 30. That links back to your central limit theorem. So we're going to get information on a population from a proportion. So you can write 0.2 either or. And again, just put in each into the calculator. So here, I don't have it expressed as percentage. If you want to express it as a percentage, just multiply it by 100. It's 9.88% and 30.12%. So that will tell you the proportion will lie within this interval 95% of the time. Population proportion, your P. That's it.